Hey guys, what's up? It's Coach Sharf. Coming back at you with another set of notes. This time it's our notes that we did on the square root method and completing the square. Again, we're only going to touch on completing the square a little bit. We're mostly going to talk about the square root method. I'm going to try to keep this one pretty brief, so I'm going to go through the problems pretty fast. So again, if you need to pause the video to get stuff down, feel free to do so. All right, so solving quadratics, 5 different ways to deal. We started with factoring, talked about graphing a little bit when we were comparing factoring and graphing to the quadratic formula at the beginning of the week, last week. Really took an in-depth look at the quadratic formula. Our last 2 methods are the square root method and completing the square. Square root method has its uses, completing the square. Technically, you can use it to get solutions for quadratics. I don't like to. It's a pain more than anything, but I will show you what it is useful for. So the square root method, we mostly use, let me move this video up so y'all can see the notes. We mostly use it when there is no bx term. Why is that not dragging? I'm sorry, guys. There we go. All right. So if I have standard form ax squared plus bx plus c equals 0, there's no bx term, okay? Got some examples here below. We're going to do these 3 examples along with a couple others coming up here in a second. The whole idea of the square root method is to get x squared by itself on one side, number on the other side, and then we're actually going to take the square root of both sides. That's why it's called the square root method. So let's look at our first problem. Before we do that, actually, I'm just going to look at this real quick. We looked at x squared minus 9, because we're about to solve that. We looked at it graphing, factoring, and doing the quadratic formula, but for all of them, we got our solutions were -3 and +3. And again, however you did it over here for the quadratic formula, -3, +3. Again, you don't have to write this down. It was just comparing. So we know those are the answers that we're looking for when we do the square root method. Okay. Now, I just realized I forgot to erase my box here. But again, that's the whole idea. When we get to this point, we're going to take square roots. So how do I get to that point? Well, we go back and do some basic algebra. I want to get x squared by itself. So I got to get rid of the -9. So I'm just going to add 9 on both sides. Give me x squared equals 9. Now I've got this x squared on one side, number on the other side. So I take the square root of both sides. Square root and the square cancel out there, leave me x, the square root of 9. Again, we're used to saying 3, but we know it should be positive or -3. If you want to reference the PowerPoint, I'll just go ahead and reference it real quick because I got it up. Again, the first PowerPoint we did, the first part of new learning, the first vocab word was that plus minus. I told you going forward, when you take a square root, you need to make sure that you have that plus minus on it. So this is where, again, that comes back into play. Because again, if you really think about it, if I stick 3 squared, or if I stick 3 into here, 3 squared is 9. But also if I stick -3 squared, -3 times -3 also gives me +9. So my answer is actually going to be plus or minus 3. Next problem. Same idea, just a different number. So I add 27. X squared equals 27. I'm going to take the square root again. So that's going to leave me x. With 27, I don't have a perfect square like I did with 9. So again, that's when I got to do my factor tree to simplify the radical. Again, we had a discussion in all of our classes about the actual word simplify. Not going to go back over that here. But again, idea is to break down our square root to get what we can outside of the square root. So in this case, I got 3, 3, 3. So we'll pair up 2 of the 3s and put one of, again, for every pair you put 1 on the outside. The single 3 is going to go back underneath. And we'll stick our, I know it's a little off kilter, but we'll stick our plus minus out in front. Again, guys, if you have any doubt, if we haven't gone over this, calculate the square root of 27 actually in your calculator. I think it's going to be, 5.1, maybe 5.2. If you do 3 times the square root of 3, so 3 times the square root of 3, you'll get the same thing if you have any doubt. All right. Problem 3. If it'll load, there we go. All right, same thing. Except now we just have a 7, so add 7 to both sides. X squared equals 7. Nope, drew through that, but that's okay. Square root, go back to the blue. So this gives me X. Try to do a factor tree for 7. I can't. It would only be 1 and 7, so I would get stuck doing 1 times 7 forever. So I can't do a factor tree for 7. So it's going to stay the square root of 7, but I still have to stick the plus minus out in front. Even in front of the square root. Again, think about the quadratic formula. You got negative b plus or minus the square root of b squared minus 4ac, but you still got the plus minus in front of this square root. So it's the same idea. All right, 4th problem, one in purple down there as I erase. X squared plus 16 equals 0. So looks pretty similar, except now my number is positive. So instead of adding something to it to cancel it out, I got to subtract. So I subtract 16. It's going to give me x squared equals negative 16. And now when I go to take the square root of this, it leaves me x, square root here. I'm going to break this down. Remember, when I have a negative square root, we're going to break out that square root of -1, and then, the number is just left by itself. This should be an automatic thing, guys. The square root of -1, we represent with I, that imaginary number. Whatever's here, if it's a perfect square like it is now, we just take the square root. If you got to do a factor tree, you do your factor tree to simplify the radical. Square root of 16 is 4, so I've got 4 times I, which is 4i. So my answer is 4i, but again, we have to stick the plus minus out in front. All right, last problem. Threw a little wrinkle in here with the 4 out in front. But again, it kind of goes back to your basic algebra concepts. We're still trying to get this term by itself, and then I could deal with the 4 and the x squared. So I'm still going to start by adding 100 to both sides. Give me 4x squared equals 100. And again, remember, I'm trying to get the x squared by itself. So I would have to divide by 4 because this is 4 times x squared. So divide by 4. That's what's going to give me x squared by itself. 100 divided by 4 is 25. Square root both sides. Gives me x equals 5. And again, stick the plus minus out in front. All right, so one last thing I want to show y'all with the square root method, but it's going to lead into a discussion about a couple other things. So I said mostly it's when we don't have a bx term when we use the square root method. There's also going to be a situation if this will load where you have something that looks like this. X minus 3 quantity squared minus 4 equals 0. We went over this in class. You learned it in 9th grade. This is called the vertex form. Again, why is it called the vertex form, Coach Scharf? I will tell you. When you have x squared equals 0, parent function, x squared. Your vertex is at 0, 0 at the origin. Your parabola would just go up like this, okay? It's called the vertex form because these numbers tell us what's going to actually happen to our vertex. So the number that's in here in the parentheses next to x is going to be my horizontal shift. Again, we'll talk about this a little more next week, but horizontal shift going left. That looks like right on your screen. So going left or right, okay? When it's inside, we actually go the opposite way that this sign would indicate for you to go. So since this is minus 3, I'm not going to go left 3. I got to go the opposite of where I think I should. So I'm actually going to go to the right 1, 2, 3. This -4 on the outside, that's my vertical shift, so up and down. This one is going to follow the sign, so I'm going to go down 1, 2, 3, 4. My vertex would be here. And again, you can kind of sketch your parabola. So that's a very basic sketch of the parabola. We can get a little more finite, however, by using the square root method to solve that. So let me erase this. I'll redraw it in a minute. Okay. So how do I use the square root method to solve this? Well, it's still kind of the same idea that whatever is being squared, I want to get by itself. So I add 4 to both sides. Gives me x minus 3 quantity squared equals 4. I can't touch this 3 until I get rid of the square. So I square root both sides to get rid of it. Leaves me x minus 3 on the left. Square root of 4 is 2, but again, we know it's going to be plus or minus. So now, again, this might be a point some of y'all remember. I got to split this up. I do x minus 3 equals 2. X minus 3 equals negative 2. So I'm going to add 3 to both sides here. Gives me x equals 5. Add 3 to both sides here. It's going to give me x equals 1. Oh, click on that. There we go. So those are my two solutions. Again, if I plug 5 into here, it would cancel out to give me 0. If I plugged 1 into here and did the math, it would cancel out to give me 0. But what this also tells me, again, I had that vertex at 3, negative 4, but it tells me my parabola is going to cross the x-axis at 1 and 5, so it lets me do a slightly more precise sketch of my parabola. Okay? So there's pretty much all the ways that we're going to use the square root method. So we have completing the square. I'm actually going to erase this graph, but I'm going to go to the next slide for a second as well, and then I'll come back to this one. Erase all this. All right, so if we go to the next slide, we call this completing the square because of this, okay? We're trying to get what we call, I didn't have this written down, a perfect square trinomial. So, you know, a regular number, when a regular number is a perfect square, 16 is a perfect square because we can multiply 4 times 4 to get it. Same idea here, okay? I can multiply the same binomial times itself to get this. So it's still a perfect square, and again, trinomial because it's 3 terms. So this is a perfect square, so how you got to figure out what you're multiplying is, you're still kind of factoring it, okay? What do I multiply to get 16 that adds up to give me 8? Well, that would be 4 and 4. X plus 4 times x plus 4. Again, if you want to check the math and multiply that, this is what you'll get, I promise. So again, when we say we're multiplying something times itself, it's just whatever that thing is squared. So x plus 4 squared. So this is why we're completing the square, because we're getting something that we're squaring. So what you have to do, if you're doing it on your own, you're going to be given x squared, you're going to be given x, you got to fill in the blank, you got to fill in the constant. How I do that is the b divided by 2 quantity squared. Again, maybe y'all remember learning it in Algebra 1. So when we're getting b, we're still following ax squared plus bx. I can't really get my c in over here, but I'll kind of put plus c to the side. So this is my b. So my b is negative 12 over 2 squared. Negative 12 divided by 2 is negative 6 squared. And then negative 6 squared turns back to positive 36. So I put plus 36 here. And when you have to do this on your own, you can still, I'll just put it down here real quick. You say, what can I multiply to get 36? 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And ask yourself, what can I use to get negative 12? Which would be 6 and 6. But you can also say whatever this number is right before I square it, this is going to be my number that I fill in here, here, and here, okay? So again, moving forward, we're not going to have the 2 split out terms like this. It's just going to be with the 1 set of parentheses squared, but it still applies that that's where we put the negative 6. So coming back to this last slide, and again, if I went over, I didn't go over it in every class. If I went over it in your class, I'm going to do this slightly different from how I did it in class. this will load. That's going to take up most of the video. All right. So we're trying to complete the square of this. When they tell you to complete the square, your assumption is this is not the correct constant to complete the square for these. So how I did it in class earlier, I added 16. Both ways are technically right, but I'm trying to keep it so it looks like vertex form. So you would add 16 to both sides and then put a blank on both sides. So what I'm actually going to do this time, let's change colors first of all. I'm going to do plus 10x. I'm going to draw 2 blanks, then minus 16 equals 0. Well, why do I draw 2 blanks? Okay. Think about, if I did it in your class, think about what I did in class. I moved the 16 over and eventually I wound up adding 25 to both sides. When I'm adding the same thing to both sides of an equation, it keeps it balanced. Since I didn't move the 16 over here, I'm not keeping it balanced. Technically, I could have put one of the blanks over here and kept it balanced, but this is what I'm actually going to do instead, okay? I'm going to do the b divided by 2 squared. So that's 10 divided by 2 squared, which is 5 squared, which is 25. So I'm going to put positive 25 here. What I'm actually going to do is put negative 25 here. Since these are both on the same side of the equal sign, 25 minus 25 is 0. So I'm not adding any actual value to this side. Again, you can just cancel this out and get back to x squared plus 10x minus 16. I just put it into parentheses for the sake of grouping, but I added a positive and negative 25. So again, it's a net cancel out, no effect, okay? But now we have this where we're trying to get our perfect square. Okay. Again, I'm looking in here. It's going to be x, whatever is here. So what I'm going to put in. So it's a positive 5. And then here I can actually combine like terms to get minus 41 equals 0. Now, if you notice, this now looks like this. So I have turned this successfully into vertex form. Okay. Again, I'm not going to go through the math, but the math is now the same over here. Again, it's a little more math to get through this point, but now that it's in vertex form, I could do the square. I'd stop to move the 41 over and then do the square root method kind of to finish it out. But I'm going to go ahead and tell you, I would get x equals negative 5 plus or minus the square root of 41. Okay. Normally, we've been leaving our answers like this, but when you go to look at this on a graph, it's going to be a decimal. So 41 is the square root is actually 6.4. So I do negative 5 plus 6.4, it's 1.4. Negative 5 minus 6.4 is negative 11.4. So I have our x, our solutions, which are also x-intercepts. Up here, I didn't touch on it, but this 16 by itself is our y-intercept. Let me circle that better. Because remember, for our y-intercept, it's still on the y-axis. I have not gone left or right any. If you don't go left or right any, x is 0. So plug in 0, that cancels out. Plug in 0, that cancels out. Gives me negative 16. It's the same idea when you talk about slope-intercept form, that the number without your x is the y-intercept. It's the same idea. So this is my y-intercept. These are my x-intercepts, my solutions. My vertex form gives me the vertex. Again, opposite sign of this, so negative 5, same sign as this, negative 41. So again, I wouldn't use completing the square to solve, but what you can do is you can use it to turn my standard form equation into vertex form to identify the vertex and the y-intercept. And again, really all you need to know is the vertex and if the graph is going up or down to draw a rough sketch. Each additional point you get, so the y-intercept, then our x-intercepts, lets us be a little more precise with our graph. And again, I'm not going to sketch it just like I did in class. I'm going to pull up Desmos real quick. I had it on YouTube. Y'all can ignore that real quick. X squared plus 10x minus 16. It's our original standard form function. There's my vertex of negative 541 at the bottom. Here's my y-intercept, and there's my x-intercepts, 1.4, negative 11.4. So that's more how I want y'all to think of using completing the square. But as I said, I'm not really going to touch on. So that's the video. I don't know what it clocked in at. I tried to make it a little shorter than the last one. I think I did get I tried to go as quick as I could. Maybe got a little long-winded at points, but I'm going to stop the recording, post this. I'll post it on the YouTube channel and I'll embed it on Canvas. And if y'all got any questions, let me know.